Good evening. Okay, good evening, everyone. Okay, so as in today's class, we will discuss some questions on series of real numbers and also on power series. Okay. Okay, and also I have solved all the problems. Those जो कि स्टूडेंट्स आप लोगों ने मुझे सेंड किया था लाइक बट द थिंग इज आई गोट प्रॉब्लम्स फ्रॉम प्रांशु ओनली. I got problems from Pranshu only. Chalo, okay. So, Shivani, you also sent some problems, but I haven't got any kind of problem from your side, beta. I got only problems from Pranshu only. When did you send them, by the way? Recently or few time back, matlab? Two days ago, okay. But I did not get any problem from your side. Chalo, okay. I will call in office, then we'll see. I would also send Khushbu, you also send some problems, okay. Or let me check it again basically. आज मैंने चेक किया तो I got only problem from Pranshu. There were 7 or 8 problems. चलो okay, ठीक है I'll make a call. Okay. चलो. So let's start today's discussion. ठीक है? Don't worry. I'll send the solutions of your problems. ठीक है? It may be network issues. It may be. ठीक है, okay. Shall we start today's class then? Chaliye, okay. So firstly, we are taking some questions from series of real numbers. Then we'll start power series. Okay. So see, it's our first question. The series this converts to series will converge always. Series will converge to its sum always. Okay. So basically, we need to find here sum of this series. Acha, okay. So here nth term say as kth term, है ना? Instead of n, you may have k. So kth term is given by kth term given by k square plus k divided by k plus 1 to the factorial. So ठीक है, we are having factorials in denominator and some quadratic term in numerator. So see, this quadratic can be written k into k plus 1, ठीक है, and divide me, you are getting k plus 1 to the factorial. So it is nothing but k minus 1 factorial, correct, because k plus 1 factorial can be written as k plus 1k into k minus 1 factorial, correct? So I'm getting this. So ultimately this series is now summation k varying from 1 up to infinity 1 upon k minus 1 to the factorial, correct? Yes. When you open the summation, okay, then you will have k equal to 1 per 0 factorial, which is 1, plus k equal to 2 1 upon 1 factorial plus 1 upon 2 factorial and so on. So it is nothing but e raised to 1, that is 2.718. So this series will converge to 2.718, this number that is on E. Clear hai? ठीक है? चलिए, okay. Let's move to next question then. It was easy question. चलो, next. Again we are having a problem on the sum. चलिए, okay. The sum of the series n square plus 5n like this. Okay, so here nth term is equal to n square plus 5n plus 5 divided by n plus 3 factorial. Okay, so in the denominator I am getting factorial and in the numerator I am getting quadratic term. Okay, so there is a possibility that I can factorize the numerator. Okay, okay. Chaliye, okay. So numerator, look at the numerator only. So numerator is what? N square plus 5n plus 5. Okay. So instead of 5, I can write 6 minus 1 because 6 has factors of 5. Correct na? So I can write here n square plus 3n plus twice n plus 6 and take it aside. So it is nothing but n plus 3 into n plus 2 minus ka 1. So the thing is, this nth term is now written as n plus 3 n plus 2 divided by n plus 3 factorial and minus 1 upon n plus 3 factorial. Correct hai? Okay ji. So see, n plus 3 n plus 2, so this will give me 1 upon n plus 1 factorial only. Okay, so after taking partial fractions, I am getting this nth term is nothing but sum of two alternating conjugative terms. It is not the sum of difference of two consecutive terms, but because after n plus 1 there should be n plus 2, but n plus 2 is missing, then I am having n plus 3. So alternating consecutive terms difference we are having, okay, in the nth term. So there is a possibility that sum can be evaluated by using telescoping series, by using telescoping sum, or you can say by using sequence of partial sum. Yesterday I told you that telescoping series, whenever I have telescoping series, that means I need to I have to evaluate the sum by using sequence of partial sums. Correct na? Okay, chaliye ji. So यहाँ पर I'll take Sn. So this Sn is nothing but summation say k varying from 1 up to n, 1 upon k plus 1 factorial minus 1 upon k plus 3 factorial. Or the thing is, just a second, एक second. We can do by or just a second, na? एक second. But एक्सपोनेंशियल भी मिल रहा है यहाँ पर. प्रांशु इज गिविंग मी आंसर 3/2. एक सेकेंड ना, जस्ट ए सेकेंड. यस, आई थिंक वो ease will goes cancel out. Yes, ease will goes cancel out. ठीक है. किस तरीके से भी कर सकते हो आप. यस, आंसर इज लाइक दिस. करेक्ट है, ऐसा ही कुछ रहेगा आंसर. सी, आइदर यू विल डू बाय द सीक्वेंस ऑफ पार्शियल सम, या तो इस तरीके से करो, आप लोगों को मिल जाएगा, या फिर हमारी जो सीरीज है, माई सीरीज इज व्हाट, समेशन व्हाट एवर आई हैव, समेशन से uk या un ही था, ठीक है, un, this un is now summation 1 upon n plus 1 factorial, ठीक है जी, and summation n varying from 1 up to infinity, no doubt, n varying from 1 up to infinity, 1 upon n plus 3 factorial. So look at here, see, I can do by the sequence of partial sum also, और हम डायरेक्ट इस तरीके से भी कर सकते हैं, because 1 upon some factorials, ठीक है, factorials, तो 1 upon factorials like such kind of terms किस में आती है, e to the power 1 के एक्सपेंशन में. करेक्ट ना? So we can use this also, and अच्छा, and runs from 0. Okay, runs from 0 to infinity. So look at it. When I put here n equal to 1, n equal to 0, I'll have 1 upon 1 factorial, ठीक है. Then n equal to 1, I'll get 1 upon 2 factorial, then 1 upon 3 factorial, and so on. Correct है? So the first sum is nothing but is of e minus 1. ठीक बात है. Okay. Then what about the second one? When you open, ठीक है, when you open it, तो n equal to 0 put करने पर 1 upon 3 factorial, फिर 1 upon 4 factorial, फिर 1 upon 5 factorial, and so on. So there are two terms missing. Three terms. 1 plus 1 upon 1 factorial plus 1 upon 2 factorial. These three terms are missing here. Correct na? So this is nothing but e minus these three terms. 1 plus 1 plus 1 by 2 factorial is like this. I can do it like this also ना. मैं इस तरीके से भी कर सकती हूँ. We can do it by this sequence of partial sums, or we can do it directly by the well-known expansion also. Yes or no? See, e to e goes cancel out. So minus का 1 minus e minus minus will become plus, and it is nothing but 5/2. So wait, e तो cancel out हो ही चुका है. So I am just getting 3/2. Yes. Clear? Or if you do it by sequence of partial sum, so automatically you will get the 3/2 answer. Anyone, any doubt here? So for this question, we we have two approaches. इसके लिए दो approaches है हमारे पास. ठीक है, चलो तो आगे वाले क्वेश्चन पे मूव करें. ये रहा हमारा नेक्स्ट क्वेश्चन. ओके, so the series is convergent if x belongs to the interval. Okay, so basically we need to find here reason of convergence for this series. Okay, so as we are having here expanding form, so we can write here nth term by observing the every term of series. So it should be what? N raised to n, x raised to n upon n factorial. Yes, है ना? 1 raised to 1 x raised to 1 upon 1 factorial, 2 raised to 2 x raised to 2 upon 2 factorial, and so on. So I will have this nth term. Okay, so as my nth term is like this, but in denominator I am getting factorial. So for the convergence, and wait just a second, is convergent if x belongs to the interval. So without loss of generality, I will consider here, see, because when you are observing the intervals, ठीक है, so every interval is having positive values of x, ठीक है, so without loss of generality I can take x greater than 0. Yes, although it is not given in your question, ठीक है, but by observing the intervals I can take x is greater than 0, so that this is going to be what? A series of positive real numbers. So that's why we can apply here root test, ratio test, जो भी हमें apply करना है. ठीक है, so we can consider it. Okay, Pratiksha saying A option. Okay, let's have a look. So I am applying here ratio test. So un divided by un plus 1. So limit n tending to infinity. Nth term is n raised to n x raised to n upon n factorial. And n plus 1th term is like n plus 1 raised to n plus 1 x raised to n plus 1 and multiplied by n plus 1 factorial. So limit n tending to infinity. So look at x raised to n goes cancel out 1 upon x. ठीक है, n factorial to n factorial 1 power से 1 power goes cancel out. So I'll just have 1 upon 1 plus 1 by n to the power n. Correct बात है ना? n plus n factorial to n factorial goes cancel out. 1n plus 1 to 1n plus 1 goes cancel out. ठीक है, if I am taking n outside, so x n raised to n to n raised to n goes cancel out. I will have just this. So 1 upon x is this. So ratios में limit मिल जा रही है this. So we know that the series is convergent if ratios limit, that is 1 upon x, is what? Greater than 1. So it is, this implies that my x is less than 1 by e, as I am taking x is greater than 0. Yes, correct. Yes. So reason of convergence will be 0 to 1 by e. Correct. चलिए, so A option is correct. Yes, चलिए, okay. Next question पे move करते हैं. Here is my next question. Okay, so the series, I have a series summation 1 upon n raised to p plus n raised to minus p converge if. ठीक है, we need to find here values of p. p की values को हमें find करना है जिनके लिए मेरी series क्या करे, converge करे. अच्छा, okay. So as n is the natural number, no doubt n varying from 1 up to infinity. ठीक है, so nth term is 1 upon n raised to p plus n raised to minus of p. चलिए, okay. So like we are having such kind of values for p. ठीक है जी, चलो. तो I'll take here some cases. ठीक है, so case first. See, such kind of things we are having here. So I am taking two cases when p is greater than 0. ठीक है, or p is less than 0. See why I am doing it, because अच्छा, okay, as you are having your nth term like this, ठीक है, such kind of nth term we are having here in this series. So which test you want to apply here? कौन सा टेस्ट अप्लाई करना चाहते हो यहाँ पर? p series second comparison test. Yes, moreover comparison test. ठीक है शिवानी, in comparison test we will use p series. ठीक है, so see, either you will take n raised to p outside or you will take n raised to minus p outside. Correct na? So if I am taking n raised to p outside, suppose karo, if I am taking n raised to p outside, then what I will have? I will have 1 plus n raised to p if I am taking outside. तो यहाँ पर क्या मिल जाएगा, n रेज टू माइनस का ट्वाइस p, ठीक है। द थिंग इज 1 अपॉन n रेज टू p, 1 प्लस 1 अपॉन n रेज टू ट्वाइस p, correct? I am taking this. Chalo. So if I am choosing here Vn as 1 upon n raised to p, then Un by Vn. This is nothing but 1 upon 1 plus 1 upon n raised to twice p. And this choice of Vn would be correct. This choice of Vn would be correct if the limit of this ratio, should be a non-zero finite number. Should be a non-zero finite number. So if I am taking that p is greater than 0, if I am taking p is greater than 0, that means p should, then this term would be in denominator. So n tending to infinity, 1 upon this term will tends to 0, so I am getting 1. Okay? So this ratio is having a non-zero finite limit whenever my p is greater than 0. P is greater than 0, so the choice of Vn is correct now. ठीक है? So first case हमारा ये आ जा रहा है, इस तरीके से आप मान लो, when p is greater than 0, then choice of Vn is correct. Now clearly my this series Vn is convergent. Vn is convergent if p is strictly greater than 1. So as I was taking here p is greater than 0, then Vn is correct. But this Vn is series is convergent if p is greater than 1. So I need to take the common values of p, and common values of p are nothing but p is greater than 1. इंटरसेक्शन लेंगे ना यहाँ पर, इन दिस केस वी आर हैविंग टू वैल्यूज ऑफ p, p is greater than 0 and p is greater than 1, so we need to take common values, that is intersection. ठीक है, तो common values are this, so this will imply that my series un is convergent if p is greater than 1. So when I am taking this case, तो p greater than 1 के लिए series convergent होगी, और if your p lies between 0 to 1, then we cannot say anything. Now obviously my series will not convergent in for these p's, है ना, इनके लिए मेरी सीरीज कन्वर्जेंट नहीं होगी, क्यों? क्योंकि Vn will not convergent. चलो ओके, लेट मी राइट इट इन मोर प्रिसाइज वे. So this will imply series Un is, and series Vn is divergent if p lies between 0 to 1. P lies between 0 to 1, then the series Vn is divergent. So I have series Un is convergent if p is greater than 1 and divergent if p lies between 0 to 1. Chalo, okay. So next case we'll take the next case when my p is less than 0. ठीक है, when my p is less than 0. So in this case, from the un, I need to take n raised to minus p outside. So if I am taking n raised to minus p outside, then I will have here n raised to twice p plus का 1. Yes or no? Correct ना? तो p अगर negative है, so in the from the un term, another term I'll take n raised to minus p outside. So if I am taking n raised to minus p outside, then I will have here n raised to twice p. ठीक है, so if I am taking here Vn as 1 upon n raised to minus का p, ठीक है, then un by Vn, this ratio's limit will be what? This ratio's limit will be what? Yes, correct बेटा, correct है. Yes, this ratio's limit will be what? p less than 0 है, तो ये ratio limit 1 हो गई, तो choice of Vn is correct. Now my Vn is convergent. This series is convergent if minus p is greater than 1. Minus p is greater than 1 implies my p is less than 1. ठीक है, so the thing is my series un is convergent if p is less than 1. So I am taking p is less than 0 and I am getting convergence for p is less than 1. So common values are nothing but p is less than 1. Correct है? So this will implies the given series un is convergent if p is greater than 1 and less than, एक second, wait. Sorry, p is less than minus का 1, sorry, हाँ, correct ना? p is less than minus का 1, करेक्ट ना? यहाँ से देखो दोनों तरफ माइनस से मल्टीप्लाई कर दोगे, p is less than minus का 1. यस, So P is greater than 1 and P is less than minus का 1. That means mod of P is greater than 1. Correct है? So my series will be convergent when mod of P is greater than 1. So I have only A option is correct. ठीक है? Because whenever P lies between 0 to 1 and whenever P lies between minus 1 to 0, then Vn series diverges and hence Un series diverges by the comparison test. ठीक है? क्लियर है सभी को? Anyone, any doubt? चलिए, okay then. So here is our next question. So this series is what? Convergent, divergence, oscillatory, or none of these? Like, so how will you show it? See, I am having two series, correct now? So I can consider this as Un series and I can consider this as Vn series. Just normal series, two series, Un and Vn. Okay. So the Un series is what? Summation sine of 1 by n, and the Vn series is what? 1 by n square. And I know this series is convergent. And what about this? What about this? This series is divergent ना? It is a positive term series. Sine 1 by n is a positive term series. हम discuss कर चुके हैं, and it is divergent. Yes or no? It is divergent ना? Divergent reason. I can take here say Un as sine of 1 by n. I can take expansion. ठीक है, the expansion is 1 by n minus 1 by 3 factorial n cube plus 1 by 5 factorial n raised to 5 and so on. Now I can take 1 by n outside. So when I retain 1 by n outside, so 1 minus 1 by 3 factorial n square and so on. Take 1 by n outside, तो क्या मिल जाएगा? 1 minus 1 by 3 factorial n cube plus 1 by n square रहेगा, n raised to 4 and so on. ठीक है? So I can take Vn as 1 by n, then not Vn, say Wn. ठीक है? Because Vn मैंने ये दूसरी सीरीज को ले लिया था, तो Wn ले लिया मैंने. I am taking say Wn is equal to 1 by n, then Un by Wn. This ratios will tends to 1 as n tending to infinity. मतलब choice of this auxiliary series is correct. And Wn is divergent. Wn divergent, that means the series Un is divergent. We have already discussed the sine 1 by n is a divergent series. Yes, sine 1 by n is a divergent series. We have already discussed this in our classes. Correct? So this series is divergent and this series is convergent. So we have a result. If I have a two series, both series are positive. Yes, here both the series are positive, and one series is convergent and another series is divergent. So overall series will be what? Divergent. Yes, correct now? So because of that result, clearly here our B option would be correct. ठीक है? Like that. So somewhere if you are, if you can observe, like your nth term is the sum of two term या difference of two term. ठीक है? And then if you are considering individual series, दो अलग अलग series consider कर रहे हो, जिनमें से one series is convergent and another series is divergent, then you can say overall series is what? Divergent. Provided both the series are should be of positive term series या फिर negative term series, है ना? Same nature की series होनी चाहिए. चलिए, okay. So let's move to next question. Next question is this. So for what values of m the infinite series this converges? Okay. So as I am having such kind of nth term, so which test we will apply here? Second comparison test, correct na? So nth term is 1 upon n raised to m. Okay. So I can take n outside. So square root of n outside ले लिया, तो 1 plus 1 by n to the square root. ठीक है जी, plus का 1. Okay. So the thing is 1 upon n raised to m minus का 1 by 2, 1 plus 1 by n to the square root plus का 1. ठीक है? So I can take my Vn as 1 upon m raised to n raised to m minus का 1 by 2, then un by Vn. This will tends to un by Vn. This will tends to 2 as n tending to infinity. The choice of Vn is convergent. Choice of Vn is correct. Now my Vn series is convergent. Vn series is what? P series, so that will be convergent if the power of n, that is m minus 1 by 2, is strictly greater than 1. That means m should be strictly greater than 3 by 2. So here our option D would be correct. Yes, our option D would be correct here. Yes, D would be correct. Easy question tha ye to, chalo bahut. Next question is this. Okay, this question is also quite easy. Can you answer me for this question? If An series converges, then n minus 1th, there is a correction. Just a second, let me make that correction here. तो यहाँ पर पूछा गया है limit of n minus 1th term divided by n to the power 1 by n. What will be the limit of this term? Very good, Pratiksha. Very good. What about other students? Cham ready? Yes, correct. Okay. Anyone? Khushbu? Yes, Khushbu, correct, beta, correct. Shivani, C. How can you say beta C? Necessary condition on AN. Yes. Jinesh, D. बिल्कुल. Oh. Jinesh, D कैसे हो सकता है बेटा? Limit. How can you say that limit is the value of limit containing n? वो तो हो ही नहीं सकता. See, the series is convergent. Given है this series is convergent. So by using our condition, if series is convergent, then nth term limit is equal to what? 0. If a series is convergent, any kind of series we have, positive, negative, alternating, any kind of series we have. If your series is convergent, then nth term limit will be 0. ठीक है? Okay. So nth term limit is 0. That means limit of n minus 1th term will also be 0. Yes. Okay. So I am applying here algebra. So according to algebra, limit n tending to infinity of an minus 1 upon limit n tending to infinity of n raised to 1 by n. Above sequence limit is 0 and below sequence limit is 1. It's a well-known limit na, n raised to 1 by n. So overall answer is 0. So we have here A option is correct. A option would be correct beta. Shivani, A option correct होगा. जिन्हें समझ में आया, A option would be correct. Chali, okay, next. Okay, so the series, I think this question we have discussed in our class. So, ये question तो हम लोग कर चुके हैं. This series converges to, and no doubt, n varying from 1 up to infinity. Supposed index is not mentioned. Supposed index is not mentioned on over any series. So always consider index start from 1 to infinity. Always, without loss of generality, you can consider it. Okay, so this series, like we have options converge to a number greater than 1, diverge to infinity, like that. Has an oscillating sequence of partialism. Never, because it's a positive term series. चलिए जी, so like ठीक है, तो nth term is what? 2n plus 1 upon n square plus n to the whole square. ठीक है जी, that is 2n plus 1 upon, I can take n outside, so n square and n plus 1 to the whole square. No beta, ठीक है, ये हमें मिल रहा है. Converge to 1, converge to a number greater than 1, converge to, है ना, like that, and diverge to. So by observing option A, B, C, हम लोगों को समझ में आ रहा है here we need to find sum. Because series always converge to sum. Series always किस पे converge करेगी? उसके sum पे converge करेगी. Correct है? चलिए, okay. So numerator term is linear, denominator term is quadratic into quadratic. See, so in the numerator I can construct such kind of terms. Because you are having n square and n plus 1 to the whole square. Yes, because 2n plus 1 I am having. So n square अगर add कर दिया और n square अगर subtract कर दिया. So this is how I can construct here n square and n plus 1 to the whole square, both the terms in numerators. Correct na? So n plus 1 to the whole square minus n square, and denominator is n square time n plus 1 to the whole square. Now I can partially fractionate, so I'll have 1 upon n square and minus 1 upon n plus 1 to the whole square. So I am getting what? Nth term is nothing but difference of two consecutive terms. Nth term is nothing but difference of two consecutive terms. So here we can do, and yes, so here we can do, yes, correct beta, yes, correct. So we can do it by using sequence of partial sums. Yes, sequence of partial sum. So Sn क्या हो जाएगा? Summation k varying from 1 up to n, 1 upon k square minus 1 upon k plus 1 to the whole square. ठीक है? So just open it. So I'll have 1 minus 1 upon 2 square plus 1 upon 2 square minus 1 upon 3 square and keep going like that, plus 1 upon n square minus 1 upon n plus 1 to the whole square. So terms will cancel out because we are having consecutive difference. Okay. So ultimately Sn is nothing but 1 minus 1 upon n plus 1 to the whole square. So here limit n tending to infinity of Sn will give you 1. So the thing is sum of the series is 1. So my series will converge to 1. So that's why yes, A option would be correct. A option would be correct. ठीक है? Next question पे चले. चलिए जी. So next question is this. The series is this where A is positive. See, as A is positive, so it is a series of positive real numbers because A is positive. So un as n raised to 3 plus A upon 2 raised to n plus A. It's a positive term series for every n. है ना? So I can apply test for a positive term series. अच्छा, convergence, divergence and all ये पूछा गया है. Okay. So which test we want to apply here? Second comparison test, because I can take n cube outside from the numerator. So A divided by n cube, and I can take 2 raised to n outside from the denominator. ठीक है? So I can choose here Vn as n cube upon 2 raised to n because limit n tending to infinity un by Vn. This will give me what? 1 non-zero finite means choice of Vn is correct. ठीक है? Now अभी हमें इस Vn series के बारे में बताना है that Vn series is convergent or divergent. ठीक है जी? Now it is not a P series, है ना? Neither P series nor the geometric series. So we have to check it convergence. We have to check it convergence. Now we can show the convergence of this series by using ratio test. ठीक है? So ratio test अगर हम apply कर रहे हैं तो I'll take limit n tending to infinity Vn upon Vn plus 1, that is limit n tending to infinity n cube upon 2 raised to n into n plus 1 cube 2 raised to n plus 1. Correct? Yes. Okay, so this will give me what? 2, which is greater than 1. So by the ratio test, my series Vn is convergent. Vn is convergent implies the series Un is convergent. Yes, so our option A is correct that my series is convergent. Okay, so while applying second comparison test or first comparison test to show the convergence or divergence of our auxiliary series, that is our Vn series. ठीक है, comparison test apply करते टाइम पर जो हमारी Vn series आती है known as an auxiliary series. So for the convergence and divergence of auxiliary series, we can use our further test like ratio test, root test. नहीं, ठीक है? तो ध्यान देना उसमें भी. जरूरी नहीं एवरी टाइम V series auxiliary series should be P series या फिर geometric series. Can I see last slide? Yes, here is the last slide, beta. Question wali. This one. Shivani, are you asking about this series? The last question. Which last question? This one. It's our second last question, by the way. किस क्वेश्चन की बात कर रहे हो बेटा? ओके, ठीक है, चलिए जी. सो हियर इज आवर नेक्स्ट क्वेश्चन. चलो, which of the following is or are correct for this series? X is in R. ठीक है, okay. See, X is in R, but I am having X to the power 2n. X to the power 2n, that means it is what? It's a positive number, and this number is already positive. So this entire number is greater than 0 for n, every n and for every x. So I can use here test for the positive term series. Okay, which test you want to apply here? कौन सा टेस्ट अप्लाई करना चाहोगे यहाँ पर? We can apply here root test, or we can apply here comparison test as well. Root and comparison both we can apply. चलो, let's apply comparison test. ठीक है, which comparison test? Second comparison test. तो x raised to 2n. Pratiksha saying B option. Only B, only at x equal to 0. Well, let me check. ठीक है, let's do it quickly. चलो, so x raised to 2n I am having. ठीक है, let's take n outside. So 1 plus 1 upon n square and minus का 1. ठीक है, so if I am taking Vn is this, if as I am applying second comparison test here. ठीक है, so if I am taking Vn is this, then un by Vn will be this. It will take limit 0. ठीक है, so the choice of Vn is not correct. Choice of Vn is not correct. ठीक है, so what next we'll do then? Apply here binomial expansion, because second comparison test always allow us to use some exponent, some expansion or some formulas and all. So binomial expansion apply किया तो 1 plus 1 by 2 n square plus 1 by 2 minus 1 upon 2 factorial and 1 upon n square to the whole square, and keep going like that, and minus का 1, minus 1 2 plus 1 goes cancel out. Now I can take 1 by n square outside. So x raised to twice n upon n. ठीक है जी. Then I'll have 1 minus not 1 by 2 minus minus का 1 by 2, so 1 by 8, 1 upon n square and remaining terms. ठीक है, so if I am choosing Vn as x raised to twice n upon n, then limit n tending to infinity of un by Vn. Un by Vn is equal to what? 1 by 2, non-zero finite. That means choice of Vn is correct. Now I need to check the convergence or divergence of what? This Vn, because Vn and un both will converge or diverge simultaneously in the second comparison test. Okay, so Vn is what? Our Vn is x raised to twice n upon n. Okay, so I can apply here ratio test. So Vn upon Vn plus 1. So x raised to twice n upon n into x raised to twice n plus 2 upon n plus 1. ठीक है जी. So I am taking here limit n tending to infinity, limit n tending to infinity. Okay. So I am just having the value of limit is x square. Okay. The value of limit is x square. सही बात है ना? So this Vn series is convergent. The Vn is convergent if the limit value that is x square is what? Greater than 1. ठीक है, x square is what? Greater than 1, and the series Vn is divergent if x square is what? Less than 1. So this will imply that my series un, this will imply that the series un is convergent if mod of x square is greater than 1. It's 1 by, oh okay, sorry bacha, sorry. Okay, it's 1 by x square. Yes, it should be 1 by x square. Thank you. Okay, so convergent if 1 by x square is greater than 1, and here divergent if 1 by x square is less than 1. ठीक है, so this convergent if x square is less than 1. X square is less than 1, that means mod of x is less than 1, and series un is divergent if mod of x is greater than 1. And what about at x is equal to plus minus 1? At x is equal to plus minus 1. At x equal to plus minus 1 here in Vn, the ratio test fails. है ना? अच्छा, okay. Clear है ना? Okay. But this Vn series as we are checking here convergence divergence of Vn series because Vn and Un will converge or diverge simultaneously in the second comparison test. ठीक है, तो fully convergence divergence किसका डिस्कस करेंगे? Vn का, because the nature of convergence divergence of Vn and Un will be same, correct? So at x equal to plus minus 1 we'll check the convergence or divergence of this Vn series. So x equal to plus minus 1 पर Vn क्या मिल जा रहा है? Simply hyperharmonic series 1 by n which is divergent. ठीक है, so the thing is series Un is divergent at x is equal to plus minus 1. So ultimately reason of convergence is mod of x is less than 1 and reason of divergence is mod of x is greater than or equal to 1. ठीक है जी, चलो, so let's go back to options. So series convergent for all x in R, no. Series converge only at x equal to 0, no. See, अगर suppose it if only would not be here, then series convergent at x equal to 0, yes, it is correct. But here we are having series convergent only at x equal to 0, so the only word से problem हो रहा है यहाँ पर. ठीक है, okay. Series convergent for all x less than 1, ठीक है. Series converge for all x less than equal to 1, no. So we have only C option is correct here. We have only C option is correct. Okay. Pratiksha saying I solved it by rationalization. Okay, and take out 1 by n common, which is 1 by n common, which is divergent. Pratiksha, yes, we can take rationalization also. We can take rationalization also here because we are applying here second comparison test, है ना? Second comparison test में we can modified over nth term, correct ना? So वो भी correct है बेटा, तो उसमें भी same ही आएगा. The same thing you will have. Vn तो same ही आएगा ना? Vn would be same. So that's why answer should be same. Pranchu saying I do by rationalization and got the same. Okay. Answer would be same, beta. Answer would be same. Of course, you have to take x raised to 2n also. We have done this question in the class. जहां पर x raised to 2n नहीं था. ठीक है, चलो, okay then. Next question is this. Consider this series. The series is convergent, divergent and all. Acha, okay. So something in exponent we are having here. Something in exponent we are having here. Correct now? So we have to apply here logarithm test. Root test. First root test, then maybe some other test. Correct now? So nth term is ln n upon ln of n plus 1 to the power n square ln n. And I can modify this basically. Okay? So see, ln n upon, I can take n outside from this n plus 1 and I can write it as ln n plus ln 1 plus 1 by n to the whole power n square time ln n. Moreover, I can write it as 1 upon 1 plus ln 1 plus 1 by n upon ln n. And the whole power is n square time ln n. Or moreover, as we are applying here what? Because modification and all. See, we have this standard statement now, like we can modify it over nth term or over given term or over given function in the case of functions. ठीक है, while evaluating limit. लिमिट इवेल्युएट करते टाइम पर ही हम कुछ मॉडिफिकेशन अपने टर्म्स में या फंक्शंस में इनमें कर सकते हैं. ठीक है, सो यस, द करेक्ट थिंग वुड बी इफ आई टेक हियर लिमिट. अदरवाइज करना ट्रू करेक्ट नहीं होता है. ठीक है, सो आई एम टेकिंग दिस, सो आई विल हैव हियर n into ln n and into ln n. Correct now? So I can do now like this, n tending to infinity, limit n tending to infinity, limit n tending to infinity. Correct है जी? चलिए, ओके. सी यहाँ पर देखिए, लिमिट n tending to infinity, Infinity by infinity to the power infinity. Correct? Undefined. Here also infinity to the power infinity upon infinity to the power infinity. Undefined. Look at it here. 1 upon 1 and this. To the power infinity. Okay. तो ये कौन सी फॉर्म बन रही है यहाँ पर? Which form we are having here in this limit evaluation? उसी के बेस पर तो हम आगे कुछ कर पाएंगे. हाँ जी. So for this, we need to take this limit n tending to infinity ln of, see here, wait. ln1 is okay. See, direct substitution put करो यहाँ पर. Take here direct substitution. ठीक है? Okay. ln1 will give you 0. ln infinity will give you infinity. 0 upon infinity will give you what? 0 na? Yes, 0 upon infinity is well-defined form. Yes, correct beta. 0 upon infinity is a well-defined form which is nothing but 0. So this is 0. So 1 upon 1, that is 1 raised to infinity form, which is our undefined form, but ऐसी form है जहां से हम limit को compute कर सकते हैं. Correct? So 1 raised to infinity form we are having. So the above limit can be written as e raised to limit n tending to infinity, take power outside, that is n ln n, and 1 upon 1 plus ln 1 plus 1 by n divided by ln n, subtract minus 1 from it. ठीक है? चलिए, okay. So let's simplify it. Limit n tending to infinity n into ln n. What can I do now? I'll take the LCM. Wait, just a second. ln n, okay. So ln n upon ln n plus ln of 1 plus 1 by n minus का 1. Limit n tending to infinity n into ln n minus ln n minus ln of 1 plus 1 by n divided by ln n plus ln 1 plus 1 by n. Its limit is 1. No, it won't be 1. 1 तो नहीं आ सकती. 1 आ गई तो काम खराब हो जाएगा. फिर तो इस क्वेश्चन को कैसे सॉल्व करेंगे? Let's have a look. Wait. So limit n tending to infinity. Look at here. This to this goes cancel out. ठीक है जी? So then what I'm getting n into ln n. See, I'm having here negative. So I'm taking this negative here. ठीक है? And ln of 1 plus 1 by n. Correct है जी? And divide में आ रहा है ln n plus ln of 1 plus 1 by n. I can take ln n outside and cancel it. Okay, just a second. See, actually ऊपर भी कर सकते थे. Same I'm taking ln n outside and cancelling it. Okay. The thing is e limit n tending to infinity n time, and also I'm taking expansion of this. I can take expansion of this term na. So I'll have then 1 by n minus 1 by 2 n square plus ka 1 by 3 n cube and so on, and in the denominator 1 plus ln 1 plus 1 by n upon ln n. See, ठीक है, ln n to ln n goes cancel out. Now look at it here. Take n outside from this. If I'm taking n outside, so n to n goes cancel out. I'm having here 1. Then I'm having here 1. Here 1 by 2n. Here 1 by 3n square and so on. Okay. So now if you are sending your n to infinity, so look at the numerator. N tending to infinity, it's 1. And here it is nothing but 0 by infinity, which is 0. So I am getting 1. So I am having here 1 by e. Okay. Value of limit is 1 by e, and 1 by is what? Less than 1. So 1 by e is less than 1. So according to our root test, the given series is what? Convergent. So here our option A would be correct. यस अनिकेत, लिमिट वैल्यू इज 1/e, करेक्ट है। यस, ठीक है। Pranshu saying I am right, but Pranshu, you said its limit is 1. You were saying the value of limit is 1, but limit value तो 1 तो नहीं मिला है। अच्छा वेट वेट, बट न्यूमरेटर e की पावर में जो लिमिट आ रहा था, anyway the thing is answer is 1/e which is less than 1, so my series is convergent, that's all. I'm not taking अच्छा, I'm not talking about the total. अच्छा, you are not talking about the total, so ठीक है, yes, okay. I was considering कि आप total की बात कर रहे हो। चलिए, okay. So the series this is, oh okay. I think we have already discussed this series, huh? In our class notes, ln n upon n. ln n upon n we are having here. It is divergent clearly, huh? ln n upon n. You can apply here Cauchy's condensation test or first logarithm test. First comparison test, because we have a relation between ln n and n. As we know, ln n is always strictly less than n for every n. Yes, ln n is always strictly less than by n for every n. So yes, we have this also, but no need to apply this. Clearly, you can write this is greater than by 1/n for all n greater than or equal to 1, 2. ln 1 is 0, ln 2 is less than 1, ln 3 is greater than 1. Yes, correct है। लेकिन I think यहाँ, हालांकि यहाँ पर इसके तो नीड ही नहीं रहा, no need to take it. We can write like this, na? It is true for all n greater than equal to 3. So it is my auxiliary series Vn, correct? Now here the series Vn is what? Divergent. So series Vn is divergent. Un is greater than or equal to Vn you are getting, and Vn is divergent, so implies that your series Un is divergent. Correct hai? So we can do it by the first comparison test. No need to apply Cauchy's condensation test every time. So our option B is correct. Series is divergent. चलिए, move to next question. Wow, next question also containing ln. चलिए जी, considering this series. Okay, so we need to find here values of p for which this series is convergent or divergent and so on. Like, chalo, okay. So clearly un is equal to 1 upon ln n raised to p, correct? Clearly it is positive, and also un is greater than, acha wait, just a second, I need to take some cases here, okay? Can I say un is greater than un plus 1 for every n? Okay, first of all answer me for this question. Can I say here un is greater than un plus 1 for every n? Oh my god, my power series is respond me bhai. Can I say un is greater than un plus 1 for every n? Un is that depend on p. Yes, correct, depend on p. So better I'll take here cases. I am taking case first when p is strictly greater than 0. Achha, okay. So if I am taking p is strictly greater than 0, then un is greater than un plus 1 for every n. Yes, in this case, okay. So I can apply here Cauchy's condensation test. So I'll consider the series a raised to n 1 upon ln of a raised to n to the power p. That is series a raised to n upon n raised to p ln a to the power p. Now here 1 upon ln a to the power b, it's a constant, I can take it outside, and summation a raised to n upon n raised to p I am getting. ठीक है. So we know in Cauchy's condensation test my given series and this considered series both converge and diverge simultaneously. Correct है. तो अभी हम इस सीरीज का कन्वर्जेंस देख लेते हैं. So I can apply here ratio test. So I am considering, let's say this term is say Wn. Wn is a raised to n upon n raised to p. So I am applying here ratio test. So Wn divided by Wn plus 1. I'll take its limit. So limit n tending to infinity. A raised to n limit n tending to infinity. A raised to n upon n raised to p. A raised to n plus 1 upon n plus 1 to the power p. So the value of limit is 1 by a, and here my a is what? Natural number which is strictly greater than 1. So ये क्या जा रहा है? Less than 1. So oh my god, what we are having here? Oh, how can it be? Am I doing somewhere mistake? No. So I'm getting that this series is divergent. Oh, I was thinking कि ये convergent होगी. Yes, correct. Answer would be 18. I was thinking कि convergent होगी, but we are having this. So this will imply this series Wn. So this will imply Wn series is divergent. Wn divergent, that means this entire series is divergent. That means my considered series is divergent. Divergent when p is greater than 0. ठीक है. So this series is divergent for all p, those are strictly greater than 0. Okay. And if you are taking p is equal to 0, if I am taking p equal to 0, then this sum will become 1. That means I'll have just one series which is clearly divergent because its sum is infinity. So let's take the next case as p is less than 0. As p is less than 0, so you can take p equal to minus ka q, where q is strictly greater than 0. So your series will be like what? Your series is nothing but ln n to the power q. Correct? Huh? You can replace p by minus q where q is greater than 0. Means this series, and clearly here nth term is ln n raised to q, which tends to what? Infinity, as n tending to infinity. So if nth term limit is not equal to 0, other than 0, nth term limit can be any. Can be any. So yes, so here nth term limit is infinity. So limit value is not equal to 0, series not convergent. And your series is what? Positive term series. So that's why your series is divergent. So when you are taking p is less than 0, then also your series is divergent. So the thing is, given series is divergent for all p belonging to R. p की हर एक वैल्यू के लिए सीरीज क्या है हमारी? डाइवर्जेंट. So yes, our option D would be correct here. D option would be correct. Yes. ठीक है. चलिए, तो नेक्स्ट क्वेश्चन. Okay, how many questions I'm having now? Okay, this question we have discussed. Okay, so do one thing, similar question, and do this question as an exercise. You guys can do it. ठीक है, do this question as a exercise. These question we have discussed in our last class. ये सारे question तो हमने last class में discuss कर ही लिए थे. Just a second. Which question is this? Okay, we have done this. ये भी हो गया था, ये वाला भी हो गया था. Okay, this is also done. This is done. This also done. Okay, I think this question is pending, huh? Okay. Will you do this? Will you do this question also as an exercise? ये वाला क्वेश्चन हो जाएगा या फिर मैं सॉल्व कर रहा हूँ? नहीं हुआ ये सम हमसे, विल ट्राई. ओके, जिन्हें सेइंग नहीं हुआ ये सम हमसे, विल ट्राई. अनिकेत सेइंग विल ट्राई. सी लुक एट. चलो ठीक है. nth term is Okay, okay, okay. I'm doing. Okay, I'm doing. Nth term is what? Say minus 1 raised to n minus 1. So just observe your nth term. See, you are having here factorial in denominator. Chalo, okay. Pi raised to 2n minus 1 and 2 raised to 2n minus 2. So pi and 2 are what? Constant. Pi and 2 are what? Constant. So you can do one thing. You can do one thing. Say pi to the power 2n minus 1 you have, and 2 to the power 2n minus 2 you have. So you can take 1 minus 1 power here and 2 to the power minus 1 aside. Correct? I can do like this. And also I'm having factorial term 1 upon 2n minus 1 factorial. So I am taking factorial and power all are same as 2n minus 1. Okay. So the thing is, this is nothing but 2. Correct? Huh? So I am having minus 1 raised to n minus 1 pi by 2 to the power 2n minus 1 upon 2n minus 1 factorial. Just adjust your terms. Just adjust your term. Now, this is my series. Now, can you identify this series? This will give you what? Alternating plus minus terms. Some fixed number pi by 2 to the power upon odd factorials. Sin x, exact sin x. Yes, because n equal to 1. Yes, correct. Exact sin x. Yes. So 2 times sin of pi by 2. So the sum going to be 2. Sum going to be 2. Exact 2 मिलेगा ना? n equal to 1, 1, n equal to 2, 3 factorial. ठीक है. Yes. So sum is what? Sum is 2. So sum alpha lies in the range. ये less than है. Yes, D option would be correct. ठीक है. Just observe किया करो terms को और कुछ नहीं. चलिए जी. So next, let's take questions from power series. Khushbu saying, ma'am, I want to ask something. May I? Yes, Khushbu. जिन्हें साइन पाई बाय 2 कैसे है बेटा? साइन का एक्सपेंशन दिमाग में रखो. पहले तो साइन का एक्सपेंशन दिमाग में रखो और इस सॉल्यूशन को देखो फटाफट से. साइन एक्स का एक्सपेंशन पता है या नहीं है? ओके. कुछ भी सेइंग हाउ टू चूज करेक्ट ऑप्शन इन एमएसक्यूज. I am little bit confused. How to choose correct options in MSQs? Beta, that depend on your question, na? Okay, अच्छा. MSQs की practice. You want MSQs? Actually, we are taking only NATs and MCQs. Okay. ठीक है. Next time we'll take MSQs also. I think in previous class we have taken some MSQs also. ठीक है. Okay. Anyway. कंफ्यूज होने का नहीं है बेटा. दैट डिपेंड ऑन योर क्वेश्चन. ठीक है. सो सबसे पहले तो क्वेश्चन हमें पढ़ लेना है. ठीक है. उसके बाद ना ऑप्शंस को, जितने क्वेश्चन ऑप्शंस को आप डिस्कार्ड कर सको डिस्कार्ड करने की कोशिश किया करो. अब बेटा ये क्वेश्चन, इस क्वेश्चन का आंसर तो मैं क्या ही दूं. हाउ टू चूज करेक्ट ऑप्शंस इन एमएसक्यूज. ठीक है. अब बस आपको आपके क्वेश्चंस का आंसर मिलेगा. जस्ट प्रैक्टिस करो. कीप प्रैक्टिसिंग. Yes, you have to practice more. Okay, I have doubt in same questions of USP. I have doubts in. Okay, you have doubts in some questions of USPs. Yes, you guys were saying na ki yes, you have doubts in USPs. So please send me those doubts. As I told you that I got all doubts from Pranshus only. Okay, so send me your doubts. I'll give you solutions. I'll send you the solutions. ठीक है. चलिए. Okay. So let's take questions from power series. Okay. As I told you earlier that in last class I'm not going to discuss any series, any theory related to power series because theory was quite easy. ठीक है. Main questions की practice का ही है. So let's take questions. And PPT मैंने नहीं बनवाया इनका, तो चलो हम questions फटाफट से solve करते हैं. Okay. So I am taking a series. I am considering a series. So I'll try to write question in a brief manner. X raised to 200 into n. ठीक है. Where an is equal to ln n to the power 200 upon n. ठीक है. Okay. Find R and exact रीजन ऑफ कन्वर्जेंस एंड ऑल. ठीक है, चलिए. ओके, शिवानी सिंह मैम, if you USB now, then we'll give you questions right now. Oh, right now I don't have USBs, beta. You guys can do one thing. Just put the question number and page number. Just put the question number and page number. Do that only. ठीक है, चलो. फर्स्ट ऑफ ऑल तो पहले फटाफट से जो थोड़ा टाइम बचा है उसमें डिस्कशन जो हमें कंप्लीट करना है कर लेते हैं, बिकॉज आई वाज प्लानिंग टू टेक like kind of approx 10 questions from power series, but possibility नहीं है आज की क्लास में तो हो पाएगा. then we'll do them in next class. ठीक है, चलो फटाफट से क्वेश्चन देखो आप तो भी. तो आई एम हैविंग दिस सीरीज, दिस इज अ पावर सीरीज. ठीक है, an is this and I need to find here radius and exact reason of convergence, exact reason of uniform convergence and all everything we will discuss. चलिए. ओके, चलिए. ओके, सो टू फाइंड द रेडियस आई कैन यूज हियर सिंगल टर्म फॉर्मूला. ठीक है, सिंगल टर्म फॉर्मूला विल वर्क फॉर एनी काइंड ऑफ पावर सीरीज विथ नो एक्स्ट्रा लाइक इंफॉर्मेशन लाइक. ठीक है ना, सिंगल टर्म फॉर्मूला हर एक पावर सीरीज के लिए काम करेगा, उसके लिए कुछ एक्स्ट्रा इंफॉर्मेशन की जरूरत नहीं रहती है. तो here r will be what 1 upon limit n tending to infinity mod of an to the power 1 upon what 1 upon the power of your x minus x naught, the power of your x minus x naught in your series. तो ये क्या आ जाएगा 1 upon 200 टाइम n. ठीक है जी. So 1 upon limit n tending to infinity, as my an is ln n to the power 200 upon n, so I'll put it here ln n to the power 200 upon n, that whole power, as it is positive so no need to put it in modulus, है ना, already positive है, so we can remove the modulo. Okay, so 1 upon 200 n. Okay, ठीक है. So I can write it like, take the reciprocal. So n to the power 1 upon 200 n divided by ln n. 200 to 200 goes cancel out, so basically ln n to the power 1 by n. करेक्ट है. ओके, सो वी कैन यूज हियर algebras. करेक्ट ना, आई कैन टेक लिमिट ऑफ न्यूमरेटर एंड लिमिट ऑफ डिनोमिनेटर. चलो. ओके, सो गिव मी द आंसर ऑफ दिस लिमिट. सो वन आंसर, यस करेक्ट है भाई, वन आंसर इज करेक्ट. यस 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 यस, आंसर इज वन. हाँ जी, सो क्लियर है, सबको मिला आंसर. तो रेडियस इज 1. ठीक है. वी नीड टू फाइंड हियर एग्जैक्ट रीजन ऑफ कन्वर्जेंस, एग्जैक्ट रीजन ऑफ एब्सोल्यूट कन्वर्जेंस, इनफैक्ट एग्जैक्ट रीजन ऑफ यूनिफॉर्म कन्वर्जेंस. एज आई टोल्ड यू अर्लियर दैट द रीजन ऑफ exact reason of convergence and exact reason of uniform convergence both are same thing, है ना. We just need to check the convergence and all at the boundary points only. Oh, Jinesh ma'am, how one? बेटा 1 ही तो आएगा न्यूमरेटर के. देखो n को इन्फिनिटी पे सेट किया तो ऊपर में क्या मिल रहा है, इन्फिनिटी. ऊपर वाली लिमिट और नीचे वाली लिमिट को सेपरेटली निकाल लो ना, एंड देन अप्लाई द अलजेब्रा. compute this limit and this limit separately, then apply the algebra. We can do it na, we can do it. I am applying here algebra, I want to apply here algebra. See, ऊपर वाली लिमिट क्या है, ये देखो इसको, लिमिट n tending to infinity n to the power 1 upon 200 n. so infinity raised to 0 form we are having, so इसको हम लिख सकते हैं e raised to limit n tending to infinity 1 upon 200 and ln n. correct है. so ln n upon n tending to infinity, this will give you 0, so e raised to 0, that is 1. similarly नीचे वाले में भी infinity raised to 0 फॉर्म आ रही है, यहां से भी लिमिट निकालोगे तो इसकी भी लिमिट 1 मिल जाएगी, एंड 1 by 1 will give you 1. so this is how we are getting here radius is 1. ठीक है, चलिए. ओके, Shyam Reddy, ma'am, before checking the endpoints, okay, Shyam Reddy saying, ma'am, before checking the endpoints, whatever the reason comes from computing limit is known as absolute reason. Am I right? Yes, beta, yes. As I told you that the reason of convergence and reason of absolutely convergence of a power series is same, except if we are getting a bounded region, then at the boundary points, convergence and absolutely convergence, वो हमें चेक करना पड़ेगा. Otherwise same. Yes, region of convergence and region of absolutely convergence for a power series is same, except in the case of bounded region at the boundary points. बस. After checking endpoint is exact. Beta, wait. Exact is a local word which given by me. ठीक है, वो मेरे थ्रू दिया हुआ था. एग्जैक्टनेस से मेरा मतलब था कि हमने एंड पॉइंट को भी उसमें इंक्लूड कर लिया है. बाय द मीनिंग ऑफ एग्जैक्टनेस इज दिस, वी आर इंक्लूडिंग द बाउंड्री पॉइंट ऑल्सो इन द केस ऑफ बाउंडेड रीजन. गेटिंग माई पॉइंट बेटा? हाँ, तो वो मतलब था. यहाँ पर एग्जैक्ट जैसा कोई वर्ड नहीं है. ठीक है, मैंने अपनी तरफ से दिया था. द वर्ड ऑफ एग्जैक्ट, द मीनिंग ऑफ एग्जैक्ट इज वी आर इंक्लूडिंग बाउंड्री पॉइंट्स ऑल्सो. ओके प्रांशु, ओके ठीक है जी. चलिए ओके. सो एग्जैक्ट रीजन ऑफ कन्वर्जेंस मींस बाउंड्री पॉइंट्स को इंक्लूड करते हुए. तो रीजन ऑफ कन्वर्जेंस इज मोड ऑफ एक्स इज लेस देन 1. ठीक है जी. अच्छा ओके, यही रहेगा ना. चलिए ओके. सो x belonging to -1 to 1. So as I want to find exact reason, that means हमें boundary points को भी include करना है. So at x is equal to -1, my series will be ln n raised to 200 upon n. ठीक है जी. And -1 raised to 200n. Correct. So it is same as ln n raised to 200 upon n. It is 1. And in fact at plus minus 1 I am getting the same series. ठीक है. चलिए, ये सीरीज है हमारे पास and varying from 1 up to infinity. So just check the convergence of this series. Does this series is convergent? Which test we can apply here? We can apply here comparison test. ln n raised to 200 upon n. This is going to be always strictly greater than 1 for all n greater than equal to 3. ठीक है. And this series is divergent. I am taking un is greater than vn is divergent, implies that my series un is divergent. So yes, at plus minus 1 this series is divergent. ठीक है. So this will implies exact reason of convergence is -1 to +1. Okay. If I am asking what is the exact reason of wait, just a second. It is the exact reason of convergence is same as exact reason of uniform convergence. Correct na? And let me repeat it again. The meaning of exactness is what? Exact reason. What is the meaning of exact reason? As I am talking about exact reason, that means I am including boundary points. मैं boundary points को भी include करके बता रही हूँ. ये मतलब है मेरा exactness का. ठीक है. और मैंने आपको बताया था the exact reason of convergence and exact reason of uniform convergence are same. Okay. So here what will be the exact reason of absolute convergence? Exact reason of absolute convergence मतलब boundary points को include करके बताना है. क्या रहेगा यहाँ पर? Exact reason of absolute convergence. Same? Yes, it would be same because at the boundary point my series is not convergent. At the boundary point +1 or -1 my series is not convergent, so it cannot converge absolutely. जब series convergent ही नहीं है तो absolutely convergence तो कहाँ से रहेगी? So it will be same as open interval -1 to 1. No need to check for the absolute convergence. आगे समझ में सभी को? Time is running. So now I am considering a series a n x raised to n. ठीक है जी. And n varying from 1 up to infinity. ठीक है. Okay. Where the a n is equal to n factorial upon 10 raised to 6n. ठीक है. Which of the following is correct? We need to find here same thing, rate r and region. We need to find here radius and region. चलिए, okay. So for the radius, I can apply here ratio test, है ना? Because if I have say n power, so ratio test तो वैसे भी कोई प्रॉब्लम करेगा नहीं, और रूट टेस्ट तो वैसे भी इन जनरल है, ठीक है. Limit n tending to infinity, an divided by an plus 1. I need to take mod. So limit n tending to infinity, as an are positive, so no need to put it in mod. So n factorial upon 10 raised to 6n into n plus 1 factorial 10 raised to 6n plus 6. Okay. So limit n tending to infinity, n factorial to infinity will cancel out. So 10 raised to 6 upon n plus 1. Okay. Value of limit is 0. Value of limit is 0. That means the radius is equal to 0. Radius is 0. That means series converges only at its center. केवल अपने सेंटर पर ही कन्वर्ज करेगी. That is only at x is equal to 0. Only at the one point, because center of this series is 0 na. This series will converge only at x equal to 0. Otherwise no. ठीक है. Okay, so I am considering a series a n x raised to n varying from 1 up to infinity, where a n is equal to 10 by 11 to the power n upon 9 by 10 to the power n plus 11 by 12 to the power n. ठीक है. So here find r. ठीक है. Radius हमें find करना है. We need to find here radius. Okay. So here which formula you want to apply to find the radius? Here which formula you guys want to apply here to get the radius? Root formula, है ना? Yes. We'll apply here root formula because in this nth term n occurring in exponent. So radius will be 1 upon limit n tending to infinity mod of an raised to 1 upon this power n. So 1 upon limit n tending to infinity 10 upon 11 to the power n upon n. ठीक है, because positive है मोड को रिमूव कर सकते हैं. And 10 by 9 by 10 to the power n plus 11 by 12 to the power n, and the whole power is 1 by n. So it is nothing but limit n tending to infinity 9 by 10 to the power n, 11 by 12 to the power n, and the whole power is 1 by n upon 10 by 11. ठीक है जी. Okay. Now, how will you find this limit? How will you find this limit? As we have a formula now, or I think I gave you the result already. If you have a raised to n plus b raised to n plus c raised to n, like some terms, ठीक है, raised to 1 by n, then take the maximum power outside. Take the maximum number power outside. Suppose if I am saying the maximum among ABC, maximum among ABC is A. So you need to take A outside, A raised to n outside. So A raised to n to 1 by n. ठीक है, क्या मिलेगा? 1 plus B by n to the power n plus, sorry, B by A, C by A to the power n, to the power 1 by n. ठीक है जी. अच्छा, limit n tending to infinity. Because A is the maximum among them. तो ये जो नंबर रहेगा वो less than 1 रहेगा. So n tending to infinity वो 0 चला जाएगा. और 1 to the power 0 will give you 1. So maximum आ जाएगी वैल्यू. Yes है ना. तो maximum we need to take outside जो common लेंगे वो maximum रहना चाहिए, है ना. ये simple सा formula है. Okay. So here maximum, I think maximum will be this. You guys can compute because this value will give you 0.9 only. And ये जो देगा 0.9 1 type something कुछ देगा, है ना. So I need to take here 11 by 12 to the power n and 1 by n आएगा तो ये पावर बाहर आ गई और ये हमें मिल जा रहा है 9 by 10 अपॉन 11 by 12 to the power n plus का 1 and the whole power is 1 by n. ठीक है, अपॉन में 10 by 11. So n tending to infinity, this tending to 0. So 1 to the power 0 will give you 1. So I'm just having 11 divided by 12 and then 11 divided by 10. That is 121 upon आंसर ये होना चाहिए इसका. एक सेकेंड, लेट मी जस्ट चेक इट. यस, आंसर इज करेक्ट. ठीक है, चलिए ओके. I'm considering a series minus 4 to the power n upon n factorial x minus 1 to the power n. ठीक है, so here also we need to find and the exact reason. Okay, so radius के लिए here we'll apply the root formula है ना, power n है, so कोई issue नहीं है. Limit ratio formula, limit n tending to infinity minus 4 to the power n upon n factorial into minus 4 to the power n plus 1 upon n plus 1 factorial. Oh, we are having here infinity na, correct? Limit n tending to infinity 1 upon minus का 4. एक सेकेंड, जस्ट a second ना, 1 upon minus का 4 and n plus 1. Okay, limit is what? क्या रहेगी limit? What will be the my radius, by the way? I will have here the value of limit is minus infinity, correct na? But radius never going to be negative. In fact, wait just a second na, wait just a second, I forgot to put it in modulus. So modulus में put करेंगे तो value आएगी infinity. तो radius is infinity, so this will imply series converges absolutely on the entire real line. Series converges absolutely on the overall entire real line. Yes, ठीक है. जो वैसे तो काफी सारे क्वेश्चन सॉल्व करने हैं भी पावर सीरीज पर, तो we will do them in next class. ठीक है,